Okay, so the f function is negative 3x to the 1/3 plus 4x to the 1/2. The g function is 5x to the 1/3 plus 4x to the 1/2. Our instructions here are to simplify and state the domain. So we have two steps here that we're going to be doing. Our problem is g of x plus f of x, so all they want us to do is add the two functions together. So I'm going to take that g of x function, 5x to the 1/3 plus 4x to the 1/2, and add the f of x function, so that's plus negative 3x to the 1/3 plus 4x to the 1/2. I want you to put it in parentheses for the first step, just because with subtraction it does make a difference. So the very first thing we can do here is we have that addition symbol. I can distribute it, but does addition change anything? No. So we're going to have 5x to the 1/3 plus 4x to the 1/2 minus 3x to the 1/3 plus 4x to the 1/2. Does anybody see what we could do next? We can combine like terms. So if I have 5x to the 1/3, I can combine that with negative 3x to the 1/3, and that's going to give me 2x to the 1/3. 4x to the 1/2 plus 4x to the 1/2 gives me plus 8x to the 1/2. And that's your answer. The other part of this problem is they want us to state the domain. So remember, domain has to do with what can I plug in for x. So let's look at where our x's are. I have x to the 1/3. If I was to rewrite that as a root, x to the 1/3 would be cube root of x. And I also have an x to the 1/2. X to the 1/2 is square root of x, right? So domain has to do with where are my x's restricted. So if I have an x to the 1/3 or a cube root of x, is that restricted ever? Can I plug in negative into a cube root? Can I take a cube root of a negative? Yeah, I can. Can I take a square root of a negative? No. So our x to the 1/3 is not restricted, but our x to the 1/2 is. How would that be restricted? Has to be positive, or could it be 0? Yeah. So when we're stating the domain of these things, we have to take the most restrictive one. So even though the cube root is not restricted at all, a square root is. And since a square root is in my expression, my domain has to be all non-negative real numbers. Okay, the reason why we say non-negative instead of just positive is because we have to include 0 as well. 0 is not a positive or a negative number. So we just say just not the negative ones. We can plug anything else in for x and we'll be fine. We just can't plug in a negative number because I can't take a square root of a negative. Okay. So example 2, we are subtracting the same two functions. So we're still using that f of x and g of x that I just gave you, but this time we're subtracting them. So I'm taking g of x, 5x to the 1/3 plus 4x to the 1/2, and I'm subtracting negative 3x to the 1/3 plus 4x to the 1/2. What do I have to do with that negative? So that's going to give me 5x to the 1/3 plus 4x to the 1/2 plus 3x to the 1/3 minus 4x to the 1/2. When I combine like terms, I have 5x to the 1/3 plus 3x to the 1/3. So that's going to give me 8x to the 1/3. And 4x to the 1/2 minus 4x to the 1/2. What happens with those? They cancel. So my answer is just going to be 8x to the 1/3. So then what's my domain? What can I plug in for x? Yeah, because it's a power of 1/3, remember x to the 1/3 is a cube root of x. That's not restricted, right? I can put positives in there, I can put negatives in there, I can put 0 in there. So my domain is all real numbers. Two new functions. F of x is equal to 4x to the 2/3. And g of x is equal to 5x to the 1/2. So two new ones. In example 3, we are multiplying f of x times f of x. Okay, so example 3, we're multiplying f of x times f of x. So I'm only going to be working with this function here. And all we want to do is plug them in. So this is 4x to the 2/3 times 4x to the 2/3. Okay, so let's multiply. 4 times 4 gives me 16. X to the 2/3 times x to the 2/3. What am I going to do with those exponents? Add them. So that's going to be x to the 2/3 plus 2/3. So that's going to give me 16x to the 4/3. We could rewrite this in terms of roots. So what would my root be? This is 16x and it's inside the root. What's the index of the root? Is it 4 or 3? It's 3. So this is a cube root, all of that being raised to the 4th power. You guys agree? Okay, so if I'm looking at this, what would my domain be? If my root is a cube root, what would the domain be? All real numbers. We are not restricted when we have a cube root. So my domain is going to be all real numbers. So for example 4, we're still going to use the same f of x and g of x, but this time we're dividing them. G of x over f of x. So let's plug it in. G of x was 5x to the 1/2, and f of x is 4x to the 2/3. The one given in example 3. Yeah. Now I give you guys a hint here. It says to get common denominators. Why would I need common denominators in this problem? Well, we don't always need common denominators to divide, but let's think about it.
Like,
kind of. When we're multiplying powers, we add the fractions, or we add the exponents. When we're dividing powers, what do we do with the exponents? When you're multiplying, we add them. When we're dividing, we subtract them. So to subtract these two things, I'm going to need common denominators, right? So what would the common denominator be? It's a 2 and a 3. What would the common denominator be? 6. So I'm going to multiply the fraction, the top one by 3 and 3, and the bottom by 2 and 2. So that's going to give me on top 5x to the 3 over 6 over 4x to the 4 over 6. Where is my exponent going to end up? In the numerator or the denominator? The denominator, why? because it's bigger. So the 5 stays on top. And on bottom we have 4x. 4 6 minus 3 6 gives me 1 6. Okay. Now let's think about it. This root, or this exponent, is actually a root, right? So is there anything in the denominator that does not belong? Yeah. If this is, I could rewrite this as 4 times the 6th root of x, and it's in the denominator. What's not supposed to be there? That root. So I need to make this exponent not a fraction anymore. So I can raise the top and the bottom by a power of, what would make this 5 over 6, right? So I can multiply, let's rewrite it, as 5 over 4 6th root of x. Now remember, when we were trying to get rid of roots in the denominator, we're looking for groups of 6 this time. So how many x's am I missing? 5. So multiply the top and bottom by the 6th root of x to the 5th. We did this right before vacation. So we're looking for what's missing here. That's going to give me on top 5 6th root of x to the 5th over 4 6th root of x to the 6th. So that is 5 6th root x to the 5th over 4. What's the 6th root of x to the 6th? X. You could leave this as your answer, but because our original functions were given with exponent or fractions in the exponent, we probably want to rewrite it. So this is going to be 5x to the 5 over 6 all over 4x. Now we're all okay. Okay? So we're not allowed to have roots in the denominator. So because this had an exponent fraction, it was a root. Okay, so we added, subtracted, multiplied, divided. Last thing we want to look at is a new type of operation called composition. So a composition of functions happens when we take one function and put another function inside of it. Okay, it's not multiplication. It's evaluating two functions at one time, basically. So in order to complete a composition, we want to start with the innermost parentheses first and work your way outwards. I will show you what a composition looks like in just a second. Okay, so example 5. We have f of x, which is equal to 3x plus 2, and g of x, which is equal to negative x squared. Don't worry about h of x. We're only going to do one example, and it doesn't have h of x in it. So don't worry about h of x. Just write down f of x and g of x. Okay, guys, so this is what a composition looks like. We have both functions in here, and we read it g of x, g of f of 3. So we're not multiplying these two functions. We're evaluating the f of 3 function first. Whatever our answer is, we're going to plug that in and then evaluate the g function. Okay, so a lot of students think that this is, we would distribute the g and then evaluate that. If you ever have a multiplication of functions, it's going to look like our example number 3. It's going to have the little dot in between them. So anytime you see something that looks like this, it's a composition, okay? So we want to start with the innermost parentheses first because we can evaluate f of 3, right? So let's find f of 3 first. So if I have f of 3, what am I going to do with that 3? Plug it into the f function. So that's going to be 3 times 3 plus 2. So f of 3 is equal to 9 plus 2. So f of 3 is equal to 11. Great. So now I can take the answer from f of 3 and plug it in right here. So now I'm going to be finding g of f of 3, which came out to be 11. So I take my answer of the innermost one and I plug it into the outside function. So I evaluate the first function on the inside, put my answer in, and then evaluate the outside function. So that's going to give me negative 11 squared using that g function. So what is g of 11 going to come out to? Negative 121.
Oh, the negative's outside?
The negative's on the outside, yeah, because the x is a positive 11. So example 7, we have two new functions. G of x is equal to 2x minus 7, and h of x is equal to x plus 4 all over 3. And I want you to find h of g of x. What is different from this composition than the previous one? There's not a number in there. It's a variable, so what are we going to do? I can't evaluate g of x any more than what I already know. So what we're going to do is we're going to take the g of x function, this guy, and plug it in. So I'm going to find h of, what was g of x? 2x minus 7. So because there was no number in there for g of x, we can't evaluate anymore. So we just take that full g of x function and plug it in for g of x. So now in the h function, everywhere that I see x, I'm going to plug in 2x minus 7. You probably want to keep it in parentheses. So that's going to give me 2x minus 7 plus 4 all over 3. So I just took g of x, the entire function, and plugged it in to the h function up here, wherever I saw x. So whatever is inside the parentheses, that's what you're always going to plug in for x, no matter what. And now we can simplify this a little bit more. 2x minus 7 plus 4 gives me 2x minus 3 all over 3. Can I reduce the 3's? No, because I have to either reduce the whole thing or none of it. So we leave our answer like this. 2x minus 3 all over 3. And that's it.